Hello everyone. From the last lecture, we start D and A block element or the transition and inner transition series elements. In this lecture, we will going to study about electronic configuration of a 3D series element as well as 4D, 5D and the 6D elements. We also discussed about anomalous electronic configuration of a chromium and a copper in 3D series. The electronic configuration is the most important. So we start this lecture with a electronic configuration of 3D series. This lecture start with electronic configuration of 3D elements. The 3D series begins with a scandium having atomic number 21 and ends with a zinc having atomic number 30. Argon is the noble gas preceding to 3D series and its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6. Here p subcell is complete and calcium having atomic number 20 belonging to S block of a fourth period has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. Here 20 electrons are enters into the calcium electronic configuration. So 21st electron is in scandium enters in the available 3D orbital. So electronic configuration of scandium is written as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Here 21st electron is entered into the third cell, that is the last but one cell, and of which d orbital or the d subcell. This electronic configuration of a scandium is also represented as argon core 3d1 4s2. The electronic configuration of a 3D elements are as given in this table. 3D series start from the scandium. So here the first element of 3D series is the scandium. This is the symbol, atomic number, and its 21st electron is enters into the 3D orbital. So its electronic configuration is 3d1 4s2. Then the electrons of the next 9 elements are enters into the 3D orbital. This is our last cell 4 and n minus 1 means 3. 4 minus 1, that is the 3, and of which d orbital or the subcell the electron is enters. So after scandium, one by one electron is enters into the 3D orbital. So titanium 3d2, 3d3 vanadium, 3d4 chromium. This is expected electronic configuration. One by one enters into the d orbital. 3d5, 3d6, 3d7, 3d8, 3d9 and 3d10. But when we discuss about the observed electronic configuration, then it is observed that the electronic, that is the expected electronic configuration and the observed electronic configuration of the chromium and copper is not similar. Here in case of a chromium, the electronic configuration of chromium, that is the expected electronic configuration 3d4 4s2, but observed electronic configuration is 3d5 and 4s1. Similarly, in case of a copper also, the expected electronic configuration is 3d9 4s2, but observed 3d10 4s2. Then why this chromium and copper shows this type of electronic configuration? This electronic configuration is called as the anomalous electronic configuration. Then the question is there, why chromium and copper show such type of anomalous electronic configuration? Here we discuss why they show anomalous electronic configuration under the heading exceptional electronic configuration of a 3D series or electronic configuration of a chromium and a copper. Here question is why chromium and copper shows anomalous electronic configuration. Exactly half filled, that is 3D5, and a completely filled, that is 3D10 electronic configuration have extra stability. It means that the elements which shows the exactly half filled electronic configuration or fulfilled electronic configuration are highly stable because they acquires extra stability. This is the rule. Then moreover, the energy difference between 3D and 4s orbital is not large enough to prevent the electron entering the 3D orbital. That means there is no much more difference in the energy of a 3D and 4s orbital. So electron is easily transferred from 4s to 3D also to get the stable electronic configuration. This to acquire increased stability, one of the 4s electron goes to nearby 3D orbital. So, in case of a chromium, one electron is transferred from 4s orbital to 3D orbital. So, its electronic configuration becomes a 3d5 4s1. Means, in 3D orbital, 5 electrons are present, which is exactly half filled. And in case of a copper, the electron is transferred from 4s orbital to 3D orbital. So, in 3D orbital, the number of electron becomes 10. So, the d orbital is completely filled and hence its electronic configuration is 3d10 4s1 for copper. So that the 3D orbital becomes half filled in case of a chromium and completely filled in case of a copper respectively. Therefore, the electronic configuration of a chromium is argon core 3d5 4s1 rather than argon core 3d4 4s2, while that of a copper is argon core 3d10 4s1 instead of argon 3d9 4s2. Because of this electronic configuration, chromium and the copper acquires extra stability. So, chromium and copper shows this type of anomalous electronic configuration to get the extra stability. Then we discuss about the electronic configuration of second, third and a fourth electronic configuration also, that is the 4D, 5D and the 6D series elements. Then first about the 4D series, the electronic configuration of 4D series element, which consists the 10 elements start from yttrium to cadmium. Their symbols and atomic numbers, and this is the electronic configuration in which the krypton core is to be considered 5d1 to 5d1 5s2 to 5d10 5s2. Similarly, the electronic configuration of 5D series elements, the 5D series start from lanthanum and ends with a mercury. This is their symbol and atomic number, and this is the electronic configuration of this series. And lastly, electronic configuration of a 6D series or the fourth transition series. These are the elements. This series start from actinium and ends with a coppernicum. So these are atomic numbers and their symbols, and this is the electronic configuration of fourth transition series or the 6D series. Here radon core is considered. Here we recall all the electronic configuration in a one table. These four series D block elements are present in the 4th, 5th, 6th and the 7th period and belongs to 3rd to 12th group. So this is first transition series or the third 3D series, which is start from scandium to zinc. These are the number of electrons present in a 3D orbital, and these are the number of electrons of each element present in a 4s orbital. Then second transition series or the 4D series, which is start from yttrium to cadmium. Here the number of electrons are given of each element present in a 4D orbitals, and these are the number of electrons present in 5s orbital. Similarly, in a 5D series or the third transition series, which start from lanthanum to mercury, electron present in a 5D orbital and electron present in 6s orbital. Here, lastly, the 6D series or the 4 transition series, which is start from actinium to copernicum, or the UUV, that is the ununbium. These are the number of electrons present in a 6D orbital, and these are the number of electrons present in a 7s orbital. In this table, we summarize the electronic configuration of all 4 series. So this is most important or the important table to study by simple way.